This is extra question in homework ch2-2. In this case, we want to find energy for x1 equals to e to the power minus 2t cosine squared t and multiplied by u of t. We want to use this formula here. Integral e to the power ax cosine squared x. The result is this. Now to find the energy, we want to integral from minus half t to t, the signal squared, and let the t goes to infinity. So this is a definition. This is a second definition for the energy. Okay, because u of t here, u of t only has values from 0 to infinity. So when t greater than 0, u of t is 1. So therefore this integral becomes from 0 to half t here. And we take the x1t squared. Now using this integral here, in this case a equals to minus half, and here that's 1/8 because a equals to minus 2, and this is a minus 2 here, and cosine squared t and sine 2t, and a equals to minus 2, that's minus 1 here, and e to the power minus 2t here. You plug in half t, that's this term, and you plug in t equals 0, t equals 0, that is 3. This is a lower integral, so minus 3, that's plus 3. And then when t goes to, when big T goes to infinity, this is a big T. You want a big T goes to infinity, and this whole term, this exponential goes to 0 very, very fast. So this whole term goes to 0 when big T goes to infinity. So the final result is 3/8. So therefore this signal, it is energy type signal. In the question 239, we need to find out the Fourier series coefficient for x1t, x2t, and x3t here. So 3 questions here. x1t, we went through this in the live Zoom session. We use Euler's formulas here, and there's a half here, and fundamental frequency here. F naught equals to 1 here. So F naught equals to 1 here. And after we decompose the signal using Euler's formula, we want to compare this sum with the general expression for periodic signal here. That equals summation from minus infinity to infinity x of n. X of n, that's a Fourier series coefficient. In the harmonics is n f naught. Here if we compare here, and n equals to 1, the coefficient is half, n equals to minus 1, that's half as well. So n equals to 2, half, the coefficient is half. N equals to minus 2, the coefficient is also half. So therefore for n equals to plus minus 1 plus minus 2, x1 n for n equals to half, and otherwise 0. In this 1 here, the subscript 1 is associated with signal x1. The second question here, the same fundamental frequency here, there is a phase shift here. We use Euler's formula here. This is the same thing here. And compare this general formula for the Fourier series decomposition there. We can obtain for the second signal, when n equals to plus 1 and minus 1, the coefficient is half. N equals to 2, the coefficient is this corresponding to this term corresponding to n equals to 2, the coefficient is minus a half j pi over 3. And for n equals to minus 2, this term is corresponding to for n equals to minus 2, so the coefficient is minus half and e to the power minus j pi over 3. So therefore, to write in a compact form, you can use conjugate here. When we take the conjugate, that will be the same. But if we don't want this minus half here, we can convert it into half. So to convert this minus sign into positive sign, we want to use minus 1 equals to e to the power j, e to the power j pi, and also equals to e to the power minus j pi. We can get rid of this minus sign and convert it into plus sign here. And therefore, using this formula here, the coefficient will be half, when n equals to 2, it will be equals to half e to the power minus j 2 pi divided by 3. So either way, in the quiz, if you use e to the power j pi over 3, you need to have minus in front. Or if you don't have the minus sign here, you need to convert into using this formula here. Either way, we're fine. The third question is this. We have minus sign alpha equals to cosine alpha plus pi over 2. This is a formula in the formula sheet we can use. And we use this because we want to use the Euler's formula of cosine. But you can also use sine directly, the Euler's formula, that's fine too. And cosine 4 pi t plus half, using Euler's formula, that will become this term. And you take the e to the power j pi over 2 here, and e to the power minus j pi over 2 here. And this is a j, this is minus j. For Fourier series, this corresponding to n equals to 2, that's j. And for n equals to minus 2, that's minus j. Therefore, there's a conjugate here. Again, this subscript 3 is corresponding to signal x3. Question 2.43 is to practice the Fourier series calculation by look at the graph. Okay. Let's look at the part A. Part A, the graph is given by this. This is a e to the power minus t is given, and you can see you need to recognize the period from the graph. Okay, in this case, the period for the signal is t. And recall, how do we calculate the Fourier series? If the period is t naught, we take half minus half t naught and half t naught. We do this integral and take the time average. That's the Fourier series coefficient. So the period is t. You can do minus half t naught and half t naught. You can also do, and we mentioned this in the video, you can do this t naught, the same thing, as long as you integral for one period. F naught here is equals to 1 over t. Okay, you plug it in, and this is a complex exponential. Plug in everything, organize a little bit. This is the result. The second one here, if you look at the graph here, this is a linear function. The period is 2t because this, you can see the waveform repeat itself every 2t second. This will be 2t here. And so therefore the period is 2t. And then we want to use this formula from minus half t to half t, because you can see this signal is symmetric from minus t to t. You want to use this formula from minus half t naught to half t naught. Whichever integral you want is whichever convenient for us, we take it. So in this case, half t naught is t, and minus half t naught, that's minus t. The linear function is t divided by big T. And the period is 2t. So for part C, the waveform is this. This is the one period from minus half t to half t. And this, you can see here, the value here is 1 and 1, and here is rectangular. And this can be decomposed as one constant plus this waveform. So this waveform is rectangular, and this is t. I call it x naught t. So this is equal to that. Why do I decompose that? That is easier to do the integral. So now use the formula here. When a equals to 0, the Fourier series is 3 divided by 2 because e to the power j is 0, that equals to 1. Remember that. When n is not equal to 0, we take this formula here. The period is t here. Now that equals to 1 plus x naught t is equals to 1 in this range from minus quarter t to t. This integral become 1. So here is 1 multiplied by this complex exponential. This is the rectangle from minus quarter t to quarter t. Value is also 1. So next, it just evaluate the integral here.